Hello and welcome. In this problem, we are going to compare the cost of electricity with cost of heat. The cost of electricity is sold in the units of kilowatt hour. Typically, a utility company will bill you so many cents per kilowatt hour. This is 10 cents a kilowatt hour. That's an exceptionally low price for California. In the middle of the night, probably the rate is like this. In general, it is like 30, 40 cents a kilowatt hour. And when we buy gasoline, for instance, another source of energy we are very familiar with, we pay, in USA at least, dollars per gallon. We are purchasing energy in both cases. In one case, electrical energy. In another case, heat release, heat. So we want to compare how much we are paying on the basis of million joule. That is, to get 1 million joule of electricity, how much do we pay? To get 1 million joules of heat, how much do we pay when you buy gasoline? So I have already opened the DeskCal and written the test code required to solve the problem. I'll just run you through this. So the data given, notice how I am putting the data in terms of variable name. Price in dollar per kilowatt hour. So obviously this is the electricity. This is our electrical energy, and then price in dollar per gallon. That is the gasoline. This is our gasoline price. Gasoline density is given 800 kg per meter cube. Note I always try to put the unit at the end of the variable name. You can name them as you like, but naming variable as X, Y, Z, A, B, C, D is a very bad practice in programming. So you want to name a variable nicely. So these are the given data. So let's see the electrical cost. That is the cost of electricity per million joule. How do you do that? Cost of electric work per kilowatt hour is given to us. Basically, I'm just equating the two variables. So if you know the per kilowatt hour price of electricity, a kilowatt hour is basically 3600 kilojoule. Notice that any comment can be with a hash mark means a comment line. So this is a comment line, here's a comment line, and here's a comment at the end of a statement. Every statement ends with a semicolon. Pretty straightforward. So the cost of electricity in the per kilojoule basis, because 1 kilowatt hour means what? A kilowatt on for 1 hour. So the energy consumed is a kilowatt hour means so many, kilowatt times seconds is kilojoule. So therefore, in 1 hour there is 3600 seconds. So 1 kilowatt hour is nothing but power times time. 1 times 3600 equals 3600 kilojoules. So for 3600 kilojoules, we know the price. So for 1 kilojoule, we simply divide by 3600. And the cost of electricity per million joule, a million joule is 1000 kilojoule. So the cost will be much higher for a million joule, 1000 times. So that gives us price of electricity per million joule. Essentially, bunch of conversion of converting unit. For the gasoline, per gallon we know the cost. The first variable, cost of gasoline per gallon, dollar per gallon. But in 1 gallon, how much mass of gasoline is there? So what we do here is we figure out this first number is 1 gallon is 3.78 liter equals so many meter cube. You can use the unit converter to verify that. So we convert first a gallon into the volume and then multiply that volume by the density, gasoline density in kg per meter cube. So therefore, we get the mass of gasoline in 1 gallon. So therefore, heat release in million joules per kg will be what? 1 kg of gasoline releases heating value of gasoline in million joule per kg is known, given to us, multiplied by the mass of gasoline per gallon. So in 1 gallon, when you burn 1 gallon of gasoline, this much amount of heat will be released. Heating value simply means when you burn 1 kg of a substance, what is the maximum amount of heat you will get out of that. for gasoline is 44 million joule per kg. So the cost of heat, dollar per million joule, we know the price of 1 gallon of gasoline, so we simply divide the price by the heat released in million joules. So all we do now is calculate. Of course, as you enter one variable after another, the calculation will be done continuously. So look at the price, final prices. Cost of heat is about this many dollar, which is 26 cents, whereas cost of electricity in this case is cost of electric work per million joule is about 28 cents at least for this particular case. You know that heat should be way cheaper than electricity, because when you convert heat to electricity, only a certain percent of heat can be converted to electricity. Typically, even in the best of power plants, it's about 40%. So you expect the cost of heat to be at least 40% cheaper than work. Anyways, this is just a practical example, but that will give you an idea that if you buy gasoline and try to make electricity, you can never compete with this utility price of 27 cents a million joule when you buy gasoline heat with 26 cents a million joule.